So when it comes to our acrylic parts, I want to talk to you about an issue that just kind of comes with the territory. It's just kind of a feature of acrylic sheet. And the problem that I want to talk about is static electricity. So oftentimes when we peel off this protective paper, we'll find that our plastic sheet has become statically charged, sometimes significantly so, like a lot of electricity, static electricity. The reason this is a concern is because it'll make our cement act strangely. And you might see this as you build. You may be applying some cement, and what you'll see is something like little hairs will shoot out of the cement, which kind of looks cool. And really what it is just really thin strands of cement being repelled from the plastic by the static charge. And while it looks cool, those little strands have to land somewhere, and that's usually elsewhere on our part, and we'll end up with strange squiggles, things like that that we might not like the look of. So I'm going to talk a little bit about how to remedy that, and I've looked at a couple different things over the years that I've been working with acrylic, and the actual solution is pretty simple. So what we want to do here is I've got a couple strips of paper, and we're going to basically just do a elementary school science project type thing. So I'm going to peel this paper off of this particular piece of acrylic here, the protective backing. And this is the friction, this peeling is the friction that usually generates a whole lot of static electricity. And we want it out of the plastic. We want that static electricity out of our acrylic before we go to put cement on, or we'll get strange effects. Alright, and I realize you can't see my acrylic very well any longer, but I'm going to take one of my little paper strips here and bring it close, and you can see that there's a static charge that's grabbing the paper, and it's really obvious on this side. Paper sticks to it. So that's an amount of static electricity that we're going to want to get rid of. And the easiest way I've found is with plain old glass cleaner and an actual microfiber cloth. Paper towels, actually, trying to wipe this with paper towels I found makes things worse. So I'm just going to put some of my glass cleaner on here. Try to wipe the entire surface with this microfiber cloth. And make sure to get both sides. And it's kind of counterintuitive because here I am rubbing it with a cloth, which is generally what you would think generates a lot of static electricity. But with the glass cleaner and the microfiber, this tends to actually dissipate all that static. So I can test again now with my cleaned piece and see, are we still attracting the paper? You can see that we aren't. Paper stays bent, doesn't jump onto the plastic anywhere. And it's just this is our low-tech way to measure how much static charge is in a piece of plastic. And when it's not pulling this paper toward itself any longer, it's not attracting the paper, we know that we have a part that is free of static to the point where we know it isn't going to interfere with our cement application. And I'm rubbing this again with more glass cleaner just to be sure. So if I had still attracted that piece of paper, I would definitely need to do this with some more cleaner. In this case, it looked like my first pass was pretty effective, and I don't really need a second one, but I'm just doing it because I needed more time to talk to you about this. So the last thing I would say about this process is that you want to make sure that the glass cleaner has had time to dry, evaporate off of your acrylic sheet before you try to cement anything to it. But now I'm passing the paper test just fine, and I can feel confident that I can apply my cement to this piece of acrylic without having it jump all over the place or act strangely. So your larger acrylic pieces are going to be a bigger problem with static than your smaller ones. And also, in my experience, I find that the transparent acrylic is also more prone to static buildup than your solid colored parts will be. But I think, since it only takes a little strip of paper, I think it's worth the time to check that before you apply cement. And if you ever do end up applying cement to a piece of plastic that has a static charge, it'll be obvious right away why I felt like this was something that we should talk about. And I just wanted to make sure that I was giving you some way to handle the situation when it happens. But that's how I recommend you proceed, is just checking your large parts and your clear parts for static, just to make sure that we can dissipate that and not get into any trouble with the cement. So you may end up, or of course you will, have small parts and smaller parts. And this one, as you can see, has a pretty aggressive static charge. It's grabbing the paper pretty firmly. So I wouldn't want to put any cement onto this part yet, because the static would interfere. So what I like to do for this part and parts smaller is I keep a little microfiber folded up elsewhere on my desk, and I just keep it just dampened a little bit with the glass cleaner. So I just put a little squirt on there, and so it's not soaked with glass cleaner, and that way you just can rub parts like this. And this is very useful, especially for much smaller parts, to kill that static. So let's see, I've given that a little rub, and now you can see no more grabbing of the paper. So this part has been discharged completely, has no static in it any longer. And that's just another tip. So if you have space on your desk or somewhere nearby, then again, just damp is enough. It doesn't need to be soaked. And it makes it easier to handle these parts rather than trying to pick up a cloth and wipe the entire surface of a part that's small or shaped oddly. So just another tip for you.